Hi everybody, welcome to my poster. This is the poster for Look Where You Go. Humans intuitively track heading direction changes with their eyes. My name is Doris. I'm from the University of British Columbia, Vancouver in Canada. As we walk through an environment, our retina experience a visual flow of information, generally called the optic flow. As we move forward, the optic flow expands and the optic flow contracts as we move backward. Viewing optic flow stimulus triggers eye movement, including the tracking of the heading directions with their eyes. And generally, the heading direction aligns with the focus or expansion, or the FOE, of the stimulus. However, these responses have been established by using small samples of observers. In other words, we don't know how generalizable and how intuitive these eye movements are. So this is what we try to study in this study by investigating eye movements to optic flow in a large group of human observers before instructions and after instructions. What the participant view is a stimulus like this, basically a random dot kinetogram, either expanding or contracting, but as you can see, there is a point where the dots appear coming from. That's the focus expansion, FOE. And just you can see the FOE shifts either, both vertically and horizontally in a dynamic and random walk fashion. And so what we look to see is how participants' eyes are able to track the FOE. So what we did in this case, we're trying to show you the example FOE and eye position traces. What we quantify the FOE tracking behavior with is by doing a cross-correlation analysis of the two position traces and quantifying how correlated they are, what's the time lag between the FOE and the eye, and also the overall 2D position error across time. But we also look into saccades, for instance, how often do saccades land on the FOE. And on the right of the poster, you're going to find 3 pieces of results that have. Result 1 shows that observers intuitively track the heading direction changes by showing there's a high cross-correlation coefficient between the eye and the FOE, a small time lag, and also a generally small 2D position error. Again, you can see there's some sort of individual differences, but in general, they have quite intuitive tracking behavior when they're uninstructed. So all these participants look at the stimulus with the instruction to free view the stimulus. Result 2 shows that this tracking behavior is sensitive to motion signal strength. We manipulate the motion signal strength by changing motion coherence, so the proportion of dots moving coherently with each other, the contrast of the dots against the background, and also the simulated translational speed. As you can see, the proportion of saccades landing the FOE increases as motion signal strength increases. This, again, is coming from observers who free viewed the stimulus. And result number 3 suggests that explicit instruction increases the tracking. As shown here, you see that, for instance, the cross-correlation coefficient is generally higher than the one you saw above. But interestingly, we noticed 2 pieces of results. One of them is that there is a positive correlation between the correlation coefficient before instruction and after instruction. So we were able to capture some of the individual differences before instruction. And also, when we compare motion signal strength against instruction, what we found is that in some cases, having a higher motion coherence or a fast speed can generally create a better FOE tracking behavior than explicit instruction under low signal strength. In other words, increasing motion signal strength without instruction can yield comparable, if not better, FOE tracking performance compared to explicit instruction. So overall, we conclude that the tracking of the FOE is intuitive in a large group of human observers based on our findings where we don't instruct participants to track the FOE and that they are able to do so. And we identify these characteristics of the FOE tracking behavior, and especially the fact that explicit understanding or explicit instruction of the task is not required for this behavior to happen. Future work, we will look into how these eye movements can be used as an indicator of cell motion perception in different populations. And we're especially interested in understanding the functional role of these eye movements for the perception of optic flow. Thank you. I look forward to hearing from you. Bye-bye.